Hi, welcome to 2.3. This is some helpful video notes on tossing an object up from a height and having it go past you. Imagine tossing a jelly bean up to catch it in your mouth and it goes over the edge of the building. So you have a lot of variables to consider and a lot of variables to actually calculate from something that is given. A couple of constant things that you do need to be aware of. The velocity at the top is 0, and acceleration is always a negative 9.8 here on Earth. So your variables to consider are y naught, v naught. Y naught is actually a height that you're throwing from. V naught is how hard you throw it. It will go into a time up to give you an ultimate height. Once you're on the way up, that's 2.2. Going up is 2.2, as if you were tossing the ball to yourself, because you want it to come back down to you. However, it's not going to come back down to you. So going up is 2.2, but coming down is 2.1. So section 2.3 combines the last two sections that we've just done. Following our path is how you want to solve every problem. So if you start with y naught and v naught, you're going to follow the path to find time up, height, time down, and the velocity at the bottom. Again, you could start anywhere, but again, you want to go through the path in order to find things. So here are the equations that you need. If you're given the v naught and the y naught, your up equations to find time up and ultimate height are linked. That's a key word. These are linked equations, linked to your down, because the only way to find time down is from the height. Okay? Because we don't have any of our down variables available to us. So we would literally have to put this equation here into this equation and simplify it. And that's just really messy. So we're not going to do it. We're going to have a linked situation, and that's okay. The second situation you're given is a y naught and a y. Again, you're up. Notice that you have a delta y here. Delta y means what is the difference between your y naught and your y? But then it's unlinked because we have one of our down variables of the ultimate height. And then the third situation is given the time up and the ultimate height. Again, we can find our initial height and initial velocity. And then again, unlinked because we do have the ultimate height, we can take 2.1 in free fall and have objects falling down. So let's go through an example of each one. Okay, so in this first example, we're given V naught and Y naught. So we want to find our time up, our ultimate height, our time down, and our velocity at the bottom. So in the situation, you're given your V naught of 30 meters per second and your Y naught of 30 meters. And you have essentially three things that you need to answer, four that you have to find, because you're going to find time up. Time up is a negative 30 divided by negative 9.8, or a positive 3.061 seconds. The ultimate height is the initial velocity squared divided by 2a. Notice it's negative, negative, so it turns out to be positive, plus the initial height, to give us a ultimate height of 75.918 meters. Our time down then, and this is linked, comes from our ultimate height, because now we're into 2.1 and we have an ultimate height. So our time down is 3.936 seconds. Our velocity at the bottom, again, uses that ultimate height of 75.918 meters to give a velocity at the bottom of negative 38.575 meters per second. Now notice that I found 4 things, but I have 3 questions because this one question says, how long is it in the air? That means a total time, adding time up and time down, to get 6.997 seconds. The second situation that you have, you're given y naught and y, and these are unlinked equations because I can find the upside of v naught and time up, and then I can find the downside, and I have all of the variables that I need to do both without using something I'm finding. So Thor throws his hammer straight up 45 meters. It makes it to 90 meters before falling back to the ground. What velocity did he throw it? That's your V naught. How long was it in the air? That's your total time. And how fast was it going when it hit the ground? That would be your velocity at the bottom. So to find the V naught, we take the square root of 2a delta y. 90 minus 45 is 45. To be a V naught of 29.698 meters per second. Our time up is the square root of 2 delta y divided by a. And again, our delta y was 45, giving us a time up of 3.030 seconds. Then we can go our downside. On the downside, we just take the square root of 2y over a to find time down. That is the square root of 2 times 90 divided by 9.8 to be 4.286 seconds. That means that our total time, how long was it in the air, is the addition of those 2 times. And our velocity at the bottom can be found by taking the square root of 2ay, those are written backwards, but it's multiplication, so it's fine, of a negative 42 meters per second. Our third situation, you're given time up and the ultimate height. So your up equations can be found by taking y naught equal to y plus 1/2 a time up squared, and v naught of negative a time up, because you have your time up value. Your time down then is from the ultimate height that you're given. So a rocket is fired up from a tower of a cliff, top of a cliff. It makes it to 3,000 meters in 15.3 seconds. What velocity was it shot at? How high was it fired from? And how long was it in the air? And what will the velocity at impact be? So now we're looking at actually 4 separate answers. So our initial velocity, that's the one we want to find first. Our initial velocity is negative of a negative 9.8 times 15.3, because time cannot be negative, of 149.94 meters per second. Our y naught is y plus 0.5 times the negative 9.8 times 15.3 squared, which should be lower than 3,000, and in this case should be 1,852.959 meters. Our time down comes from the ultimate height of 3,000 to be 24.744 seconds. Our velocity at the bottom, again, comes from the ultimate height of 3,000 to be a negative 242.487 meters per second. And our total air time is time up and time down together of 40.044 seconds. You're going to have problems to do today on your assignment. Thanks for watching.